Hey everyone! Today we're going to tackle what is arguably the single most important concept in all of programming, functions. Seriously, whether you're in Python or any other language, getting a handle on functions is an absolute game changer. So let's dive right in. So here's our game plan. We're going to start with a really common problem, one that drives every new coder nuts. Then we'll introduce the hero of our story, the function. We'll break down exactly how to build them and use them, step by step, until you're totally ready to create your own. All right, let's kick things off with a problem that I promise you every single programmer runs into at the very beginning. You're definitely going to recognize this feeling. You know that feeling, right? That little sense of déjà vu, where you find yourself just copying and pasting code and then making these tiny little edits. Yeah, that's the one. It's a huge red flag that there is a much, much better way to get things done.
So let's say you want to greet someone. Super simple, right? You write one little line of code and boom, you've greeted Najam. It works, no problem. But the trouble starts the second you need to greet somebody else. To greet Hamza, you have to go back, copy that line, paste it, and then manually change the name. I know it's a small change, but just imagine doing this for 100 different names. Or what if it was a block of code that was 20 lines long? It gets old really fast.
And look, this isn't just about it being annoying. It's a real problem for your code. Doing repetitive work means you're going to make mistakes. It's just human nature. And as your program gets bigger, it just becomes this tangled, messy nightmare. There has to be a better way. And that better way, the elegant tool that saves us from all this repetition and chaos, is the function. It's the hero we've been waiting for. So what is a function? At its core, it's just a named, reusable block of code. Think of it like a recipe. You write down the instructions for a chocolate cake, just once. Then, anytime you want a chocolate cake, you just follow that recipe. You don't have to reinvent it every single time. And creating a function is actually super straightforward. You start with the keyword def. That's short for define. Then you give your function a name. After the name, you add parentheses and a colon. And then all the code that belongs to that function gets indented right underneath. And that indentation is absolutely key. It's how Python knows what instructions are part of the recipe. Okay, this next idea is absolutely crucial for understanding how functions work. There is a massive difference between creating the instructions and actually telling something to follow them. This is a fantastic way to think about it. Defining a function is like writing down the recipe for tea. You've spelled out every single step perfectly, but you don't actually have any tea yet. Calling the function is like actually following that recipe to brew a cup. That's when the action happens. Let's see how this looks in the code. Right here, we have defined our greet function. We've written the recipe. Now, if you run just this code, guess what happens? Absolutely nothing. The computer now knows how to greet someone, but we haven't actually told it to do it yet. So how do we make it happen? We call the function. We just write its name, followed by those parentheses, greet. And boom, just like that, the code inside the function runs and hello person pops up on the screen. We've solved our first problem. We've got a reusable piece of code. But you know, our function is still a little generic. It always says hello person. The real power kicks in when we can give our functions information to work with to make them dynamic and personal. A great way to think of a function is like a machine, a meat grinder, right? You put meat in, you get minced meat out. A generator, you put fuel in, you get electricity out. Well, our functions work the exact same way. You can give them some data, they'll process it, and they'll produce a result. The way we tell our function machine what kind of input to expect is with a parameter. It's just a placeholder variable that you put inside the parentheses when you're defining the function. It's like a labeled slot on the machine waiting for you to put something in it. And the actual data that you put into that slot when you use the function, that's called an argument. So the parameter is the placeholder, like name. The argument is the real deal, the actual value, like the string Najam. And check this out. This is what it looks like in action. We've upgraded our greet function so that it now accepts a name parameter. So now, when we call it, we pass in an argument like Najam or Hamza. The function takes that argument, plugs it in as the name, and now we can greet anyone we want with the exact same block of code. That's reusability. So far, our functions have only done things, right? They've printed stuff to the screen. But what if we want a function to calculate something and then give us the answer back so we can use it later on? For that, we need the return statement. Take a look at this add to function. It takes two parameters, a and b.
Inside, it adds them together and stores the sum in a variable c. Then, and this is the key part, it uses the return keyword to send the value of c back out. So when we call add2 1020, the function effectively returns the number 30, which we can then store in a variable like result. Now, here's one critical thing you have to remember about return. It immediately ends the function. The second Python hits a return statement, the function is over, done. It packs its bags and goes home. Any code you write after the return line inside that function will never, ever be executed. Okay, let's take a breath. We've gone from a really tedious, repetitive problem to an incredibly powerful and flexible solution. We've learned how to define a function, how to call it, how to pass data into it, and how to get data back out of it. And really, it all comes down to this core principle in programming, DRY, which stands for don't repeat yourself. This isn't just about saving yourself some typing. Imagine you find the bug in a piece of logic that you've copied 10 times. You'd have to go find and fix it in 10 different places. With a function, you fix it once, in one spot, and it's corrected everywhere. That is what makes your code clean, manageable, and truly powerful. And now, it is time to put all of this into practice. Your challenge is to build a simple calculator function. It should take 3 arguments, 2 numbers, and a string for the operation, like add or subtract. Then it should return the result. This is a great way to combine everything we've just covered. So go ahead, give it a try. What will the first line of your function look like?